is about the remainder and factor theorem. Now, before we start with actual examples, there are some vocabulary and theory that you need to know first. Let's say I tell you to work out 25 divided by 7. You can rewrite it in this notation, 25 divided by 7. Then you'll get an answer of 3 remains 4. Is that correct? Now you need to know, what do you call this 7, what do you call the 25, and what do you call the 3? The 7 is the divisor. The 25 is the dividend. The 3 is the quotient. And the 4 is the remainder.
So I'm going to have to read the article along the way.
No.
Oh.
But that wouldn't be a bad thing. Okay, let's look at the remainder theorem.
What does the number 3 say?
Quotient. The remainder theorem and the factor theorem is important for tomorrow's lesson. So you need to understand how to get the remainder without doing long division, and how to get a factor without dividing and without factorizing. Wow, that's great. Okay, let's say we have fx. That means we have a function. It can be a parabola, straight line, a cubic function, anything. And we want to divide it with ax minus b. Then you'll get an answer, and there will be a remainder. Remainder what? Okay. Now this remainder has a specific formula. Without factorizing, without dividing, you can get the remainder with a specific formula. And the formula is, you have to take b and divide it with a. That will give you the answer of the remainder. Yeah, very nice. And this divisor must have a specific form. You must have something with x, there must be a minus, and then you have to have a constant. If your divisor is in this format, you can work out the remainder.
Is the divisor always going to be in that format?
No, we have to rewrite it in that format. So let's look at a few possibilities for the divisor. I want fx, and I want to divide it with, let's say, x minus 1. What will the remainder be? 1. Okay. First we need to check the format. There is a minus. A is 1, B is 1. So to get the answer of the remainder, I take my function and I substitute the x's in the function with 1 over 1. And that means I have to look for f of 1. So you substitute the 1 in all the x's there, and that will give you the remainder. Very easy. Okay, it will make sense when we do an example. Okay. Let's take another one. If the divisor is x plus 2, fx divided by x plus 2. Remember I said there must be a minus, so we have to rewrite it as x minus negative 2. Then the 1 will be a, and the negative 2 will be my b. So to get the answer of the remainder, I take the b, negative 2, and divide it by 1, and that will be f of negative 2. So if I replace the negative 2 into the function, all the x's, I will get the remainder's answer. Remainder 1. The third one, 2x plus 1. There is not a minus there, so I have to rewrite it as 2x minus 1. My a will be 2, and my b will be negative 1. So to get the answer of the remainder, it will be negative 1 over 2. So if I substitute negative a half into fx, all the x's, I will get the answer of the remainder.
When we say substituted with 2fx, you mean into 2x plus 1?
No. Fx can be x squared minus 4x plus 3. So you substitute the negative half into all the x's, and then you get the remainder. Let's look at the last one, 3x minus 5. If I have to divide fx with 3x minus 5, what will the remainder be? So I substitute b, which is 5, over 3 into fx x's, and then you get the answer of the remainder. Does that make sense?
Yes.
Okay. Yes?
Is the remainder always going to be a whole number?
It can be variable. No, it will be a whole number because you substitute the x's with a number. Now let's look at factors. Let's look at factors. If I tell you, give me the factors of 8, it means that which numbers divide properly into 8 without any reminders. It can be 1, 2, 4, and 8. So these are the factors of 8. When do we know that it's a factor? When there's no remainder. So if the remainder is 0, we have a factor. What is the formula for remainder? F of b over a. And if that is 0, then it means that this one is a factor of fx. Okay. Let's look at the factor theorem.
So like, is it like before where if the function you give us will be gx, the formula to gx is b variable, is that always?
Ask again.
If they give us a function gx, will it be g b over?
Yes. Okay. Let's say we have fx. What whatever fx might be, and we divide it with x minus 2. What will the remainder be? F2 over 1. So the remainder will be f of 2 over 1, which is 2. Okay? If this remainder is 0, what does that mean? What is a factor?
The device.
The divisor. This means that this is a factor. How do I get that? If you only have that, and you work out f of 2 is 0, you have to write, therefore, what is a factor? How do I get that what? In this case, x equals 2. If I take the 2 over to the left-hand side to x, what do I get? X minus 2. So x minus 2 is a factor. That means if I divide the function with x minus 2, the remainder will be 0.
So you always just say the divisor is a factor
if the remainder is 0.
So you write the divisor as it is.
Yeah. And then from this, you get the 2. Then you work out, you see it is 0. Therefore, that is a factor. Okay.
And what do you mean x equals 2?
That one means that x is 2. It's in the place of f. X. X is 2. Therefore, if I take the 2 over, I will get x minus 2. Okay. If I tell you f of 3 is 0, what will the factor be? X minus 3 is a factor. If I tell you f of minus 4 is 0, what will the factor be?
Yes.
No. X plus 4 is a factor. Okay. Let's look at our first example. Now everything will fall in place.
But how do we know that negative 4 from negative 4 over 1, but negative 4 from negative 2?
It will still give you negative 4. Negative 16 over 4 will give you negative 4.
And so sometimes you don't give us the divisor, we have to work it out.
Yes, and to get the we'll come to an example for that question. Okay, let's look at our first example. I tell you if x equals negative x to the power of 3 minus 2x squared plus 5x plus 6. That's my function. Prove that x minus 2 is a factor. So now I give you the divisor. How do I prove that something is a factor? The remainder must be 0. Okay. That's the question that you must ask yourself. The remainder must be 0. What is the remainder? The reminder's formula in this case? F of 2. So f of 2 must be 0.
And you just always say that x must be alone, that's how you get the thing.
Yeah. So now you have to prove that if I substitute 2 into this function and I get 0, it means that this is a factor. Are you all following me? So let's start with f of 2. f of 2 equals, I have to substitute the 2 into all the x's. Remember, when you substitute, you have to substitute in brackets. Minus 2 to the power of 3 minus 2, 2 squared plus 5 times 2 plus 6. 2 to the power of 3 is 8 times a minus is negative 8. 2 to the power of 2 is 4 times negative 2 is negative 8 plus 10 plus 6. Negative 8 minus 8 is negative 16. Negative 16 plus 10 is negative 6. Negative 6 plus 6 is 0. So the function, when I substitute 2, will give me a 0. What does that mean? Yes, the remainder is 0. Therefore, x minus 2 is a factor. And this is how you answer your questions. You have to show how you substitute, and you have to make the conclusion. Example 2. Fx equals x squared plus 4x plus 3. We have that one. Yes. Right? The question is find a factor. That's what your question is. Find a factor. Now, how do I know what will the factor be? With what must I divide here so that I get a remainder of 0? It's trial and error. So what we do is, I take the number line, and then I first substitute 1 and see if I get 0. If not, I take negative 1 and I substitute negative 1. If that doesn't give you 0, you take 2. If that doesn't give you 0, you take negative 2. Okay, so let's start with,
And can't you just make y equals 0? Just equal to x value.
yes, in this case we can. But what if it's acute? Then we can't factorize. Okay. So we start with f1, substitute the 1 first. 1 squared plus 4 times 1 plus 3 will give you 1 plus 4 plus 3. Oh, this is 8. So, x minus 1 is not a 0, not a factor. Let's look at if negative 1. Substitute the negative 1. Squared plus 4, negative 1 plus 3. It's 1 minus 4 plus 3, it's negative 3 plus 3 is 0. There's 1 that has a 0. Therefore, x plus 1 is a factor. Now let's say I give you a huge equation, x to the power of 4. You can't factorize that. You can't do long division. And if you try and trial and error all of them, and you get to 5 and minus 5, you still don't get 0. What is the quickest way? So now I'm going to show you how to use your calculator to get to this number that works. I want you to do it with me. You go to mode, and I want a table with x values, and if I substitute this x values, what will the y answer be? All of them. So what must I look for to see if the remainder is 0? The y must be a 0 somewhere. Then I know this x is a factor. Okay, so I want the table. Then it gives you the start of the equation. I want x squared, and there's a red x. To get to that red x, you need to press the alpha key. So alpha x gives me an x. I square it plus 4x plus 4 alpha x plus 3. And then you press equal. Now it asks you, do you want to do another equation? No, I don't. So you just press equal. Where do you want to start? Okay, let's start at 1, and we take a few of them up until 5. So let's start at 1 equals. Where do you want to end? At 5 equal. How much do you want to step? I want to step 1 each time to get to the 5 equal. And there it gives you the table with all the x's and all the y's. But if you go down with your arrow, you'll see that no fx, no y is a 0. Now I have to choose another range. So let's go over the 0, and we choose from -5 until -1. Unfortunately, you have to go back to mode 3 table. So it's alpha x squared plus 4 alpha x plus 3 equals. Now gx equals. Start, I want to start at -5 minus 5 equals. End, I want to end at -1. -1 equals. Step 1 equals. And now it gives you a new table. And I can see a 0 next to -3. There's a 0. That means that the x, which is -3, will give you a 0, and that means that the -3 is part of a factor. What will that factor be? X plus 3. Okay. To get back to your normal calculation function, you press mode and compute 1. So now it's normal again. So that concludes the remainder theorem and the factor theorem. Are there any questions? You know how to get to the remainder and how to get to the factor. We're going to need that for tomorrow's lesson when we do the cubic function. It's a new function. You already know the straight line, the hyperbole, the parabola, the exponential. Now we get to the cubic function tomorrow.
So what's a graph?
That's a graph. Yep. Your homework for tomorrow today we did the remainder and the factor theorem, and we did examples 1 and 2. So your exercise homework is exercise 5. It's more or less on page 22, 23. And you have to do number 1 till 4.